Hello and welcome everybody. I welcome you all in the second lecture of Human Eye and Colorful World. So let's begin this class without wasting our time. So guys, in this slide we will study about the defect of vision and their correction. Okay. So what are these defect of vision? Before understanding these defect of visions, I will tell you some little information about the far point and the near point. Far point and the near point. Okay. So guys, far point is a point till when a person can see an object. So what is our far point? So our far point is at infinite distance. Why it is an infinite distance? Because we can see the object which are placed at infinity. Okay. So what can be the examples of the far point? So basically you can see a sun. You can also see moon. They are far from us. They are far away from us. Even though we are able to see it clearly. So that's why guys, we can say that the far point of an human eye is infinite. Now guys, let's talk about the near point. So what is a near point for an human eye? So basically guys, the near point of an human eye is 25 centimeters. I think we already know this fact that near point of an human eye is 25 centimeter. Now guys, let me give you a quick example. How can you understand that a near point is 25 centimeter? So, let's suppose you are sitting on a chair and you have a book on your hand. So, if you keep close, if you keep, or you can say, if you bring this book closer to you, then what happens? You are still able to see the words written in that book. Okay, now you have to keep this book at 25 centimeter distance away from your eyes. So now what you observe, you are still able to see the words written in that book. Okay, now what you have to do, you have to keep it more closer to you, or you can say you have to keep it before the distance of 25 centimeter. Now guys, what happens? The words will start to appear to be blur. Okay, you will see the blur images of the word written in that book. Okay, if you don't believe me, you can definitely do this practical at your home. Okay guys, so thus I can say that the near point of an human eye is 25 centimeter. Okay, so these are the far and near point for an healthy eye. Okay, for a healthy eye. But what happens when there is some defect in the vision of an eye? Then what happens? These far point and the near point is changed. So basically, let's suppose if there is a boy who is sitting at the last bench of your classroom. Let's suppose this is a boy sitting at the last bench of your classroom. Now, if he is not able to see the words written on the blackboard far away from him, then it simply means it is a defect of vision. Okay, if the words written on the board is not clear to him, or it is appearing to be blurred to him, it simply means that he might have some defect of vision. Now guys, if there is a person who is not able to read a book which is far from 25 centimeter, or you can say which is near to him, and it is away from the near point, even though he is not able to read the words on that book, so it simply means it is also a defect of vision. Okay, so I hope guys you might have been able to understand what are the defect of vision. Okay, now guys, let me tell you what all defect of visions we are going to understand in this lecture. So, the first vision, these are the examples of the defect of vision. First vision defect of vision is myopia. Myo, let me erase and let me write the correct spelling of myopia. Okay, so this is myopia. This is the first type of defect of vision. Now, the second type of defect of vision is hypermetropia. Hypermetropia. These two visions are just opposite to each other. Okay. Now, the third type of vision is presbyopia. Presbyopia. This is another type of vision. I hope guys these things are clear to you. In the upcoming slides, we will be discussing these visions more deeply. Okay, so for now on, let me read this definition. So sometimes the eye may gradually lose its power of accommodation. In such condition, the person cannot see the objects distinctly and comfortably. The visions become blurred due to the refractive defects of the eye. So basically guys, what is the cause of these defects of vision? So the cause of the defects of vision is that our eyes loses the power of accommodation gradually. Okay, so these defects are more often found in the old peoples because their eye gradually lose its power of accommodation. And I hope that I do not need to explain this power of accommodation again, because we know that power of accommodation is nothing but the power of an eye, or the ability of an eye to adjust the focal length of the eye lens. Okay guys, I hope these things are clear to you. Now let's move on to the next slide and let's talk about the other things which is there. Okay guys, so here I am. Here guys, we will discuss about the myopia and what is an myopic eye. Okay, so myopic eye is nothing but an eye having this defect of vision which we call myopia. Now guys, there is another name for myopia, and that is, let me change the pen. So another name for myopia is short sightedness. These two names are frequently asked in the examinations. So you do not need to be confused, because the myopia is nothing but the short sightedness. Let me highlight it for you. Okay guys, now let's study, or let's read the definition, then I will explain you what is myopia. So it is a deficiency in the human eye that causes a person to see close items clearly but not distant object clearly. And myopia is due to excessive curvature of the cornea or the elongation of eyeball. Now guys, let's talk about the explanation of this myopia. So basically what happens, sometimes we think that myopia is known as short sightedness. So it can mean that a person who can see the objects, or you can say who cannot see the objects near to him, is known as short sightedness. But it is completely wrong. Okay, it is completely wrong. Basically, a myopic eye can see the close items clearly, but it cannot see the distant object clearly. So you do not need to be confused here. Okay, if short sightedness is given, or it is given that a person is having myopia, then it simply means that this person can see the object close to him but cannot see the objects at distance, or you can say far away from. Okay, so myopic eye, or I will write myopia, person can see the object which are close to him but cannot see the object for, or you can say distant object clearly. Okay guys, I hope this point is clear to you. Now, why this myopia happens? So basically guys, this myopia happens due to the excessive curvature of the cornea. This happens due to the excessive curvature of the cornea. So let's suppose this is your cornea and there is excessive curvature. So what will happen? The image will form before the retina. The image will form before the retina. So I will tell you later that how images form before the retina. For now on, you just need to remember this point, that myopia happens due to the excessive curvature of the cornea, and the second point is elongation of eyeball. The second point is elongation of eyeball. Now guys, let's move on to the next slide and let's talk about the correction of myopia. Okay, so basically what happens, this is an image of the image formation of an myopia eye, or you can say myopic eye. So this is your lens, okay, and these are the rays coming from an infinite object. And we know when the rays are coming from infinity, then these rays are parallel to the principal axis and they are coming like this. And after the refraction, what happens, due to the excessive curvature of this cornea, these rays meets before the retina. These rays meets before the retina. So the image cannot be formed at retina. It is formed before retina. It is formed where? Before retina. So that's why guys, what happens, this type of defect comes. So basically guys, now let's talk about how can we correct this defect. Okay, so what do we need to do? We need to cancel out this effect. Okay, because what is happening here, the rays are converging a little bit closer to the lens. Okay, here the rays are converging before the retina. So it means the converging power of this lens is higher. Okay, now if I use a concave lens before an myopic eye, then what happens? This concave lens is a diverging lens. This concave lens is a diverging lens. And why it is a diverging lens? So let me tell you. Let's suppose this is your concave lens, then it will diverge the rays like this. We know that it is diverging the rays like this. So basically guys, what will it do? Let's suppose this is a myopic eye and this is a concave lens, and these are the rays coming parallel to this principal axis, and after the refraction from the concave lens, this concave lens diverge these rays, and after the diversion, these rays will form an image on the retina. These this will form the image on retina. Okay, so now we can correct this type of defect by the use of concave lens. Okay guys, so you can see this is an image of a person having myopia, and this is an image a person having myopia but with concave lens. Okay, so in this image number first, you can clearly see that the image is formed before the retina, but in the second image the image is formed on the retina. So thus this defect has been corrected by using the concave lens. Okay guys, so if you are asked how can we correct the myopia, then you will simply say use of concave lens. Okay, use of concave lens. And why this defect happens? Then we will answer this defect happens due to the excessive curvature and due to the excessive length of the eyeball. Okay, let's suppose if this eyeball is larger, then also the image will form here, not on the retina. Okay, so it might be a reason. Let me draw. This is your retina and this is the image formed. So this can also be the reason of the myopia. I hope guys these things are clear to you. Okay, let me again explain it to you in a quick way. So this is your eyeball. These are the rays coming parallel. After the refraction, the image is being formed before the retina. So a person having myopia cannot see the image clearly. But in the second picture, what is happening? This person is having concave lenses. So these concave lens diverge these rays, and because of the diversion, now these rays will form image exactly on retina, and thus this defect is corrected. Okay, now guys let me read this. Since a concave lens has an ability to diverge incoming rays, it is used to correct this defect of vision. So the same thing is written here, which we saw that concave lens has the ability to diverge the rays. So that's why it is cancelling out the effect of converging rays. Okay, what is happening in this first case? The rays are converging. So that's why this diverging lens is used so that it can cancel out this effect. Now, the image is allowed to formate the retina by using a concave lens of suitable power as shown in the given figure. So basically it is written that the image of this object will appear on the retina so that we can clearly see it. So now guys, after understanding this concept, let's move ahead to the next slide and let's talk about what is there for us. So here we are. Now guys, here we will discuss the examples. Okay, so we will be studying about some examples so that our concept will get clear more. So this is the first example, that what can be a 4-point of a myopic person. What can be a 4-point in case of a myopic person? So what is myopia? We all know that a person having myopia can see the near image clearly, but he cannot see the image placed at far away. Okay, so now you tell me, can he be able to see the image, or you can say the object, at infinite distance? No, because the person is having myopia, and myopic person only be able to see the nearby objects. So will he be able to see this 1 kilometer object distance? No, he won't be able to see it. Okay, so can he see this 1 meter object? Then of course he can see the object placed at 1 meter. Okay, so this will be our answer. This will be our answer. Okay, then now you tell me that can he see the object at 1 centimeter? No, he cannot see, because we know that what is the near point of a person. We know that the near point is 25 centimeter. Even if we have a normal eye, then also we won't be able to see object at 25 centimeter before. So this is the right answer. Now guys, let's talk about the second example. So what can be the reason of myopia? What can be the reason of myopia? So as we discussed that the reason of myopia, the first, let's talk about this first reason, eyeball being too long. Of course, we saw it. The eyeball being too long is a reason of myopia. So this is true. Now, let's talk about the second option, high converging power of eye lens. So it is also true. Okay, because the lens has high converging power, so it converges the rays before retina. Now guys, let's talk about the third option, high diverging power of eye lens. No, it is not true. High diverging power of eye lens cannot be the true option. So the right options are option number 1 and 2, and in option number 4 you can see both 1 and 2. So of course this is the right answer. So let me highlight it. Both 1 and 2 are the right answer of this question. I hope guys these things are clear to you. Okay, now let's move on to the next slide. Okay guys, so here we are. Here we have other example to solve. So a person cannot see the objects beyond 30 centimeter clearly. Suggest which lens should he use. Okay, so basically, first of all, we have to recognize that what type of defect does it person have. So here it is written that a person can only see objects before 30 centimeter. He cannot see the object beyond 30 centimeter. So let's suppose there is an object at infinite distance. So this is, let's suppose, the eye of that person. This is the eye of that person. Okay, so can he see this object? No, he won't be able to see this object. Okay, he can only see the object which is placed before 30 centimeter. So now guys, you tell me what is the far point of this person. So the far point of this person is 30 centimeter. Far point of this person is 30 centimeter. Now you can ask me that what is far point. So I told you that a far point is a point until when a person can see an object. So here a person can only see the objects till 30 centimeter. So it means the far point in this case is 30 centimeter. Now what happens? We know that if this infinite object cannot be seen by this eye, so this eye is having myopia. So what can we do to correct this effect? We know that we should use a concave lens. We should use a concave lens to correct this effect. Okay, because what a concave lens do? let's suppose this is your concave lens, then what this lens do, this lens will form the image of this infinite distance object at 30 centimeter. Okay, now if the image is at 30 centimeter, then this image can be clearly seen by this eye, because this eye can see the objects at 30 centimeter. Okay, so if the image of this infinite distance can form, or you can say if this image is formed at 30 centimeter, then it will be seen by this eye. So now let's find out the focal length of this lens. Okay, let's find out the focal length of this lens. So how can we do that? We know that 1 upon v minus 1 upon u is equals to 1 upon f. This is the lens formula. This is the lens formula. Okay, now guys, we need that this should be the image distance. The image distance should be 30 centimeter. Let me draw it. Image distance should be 30 centimeter. Now, because this is at left side of the lens, then I will write it minus 30 centimeter. I will write it minus 30 centimeter. Now guys, let's talk about the object distance. So you can see that the object is at infinite distance. Object is at infinite distance. So it means the value of u is minus infinite, because this is also left side of this lens. Now I am interested to know the focal length of this lens. So how can I calculate it? I will simply put these values in this formula and I will get the focal length. So let me write it here. 1 upon v is minus 1 upon 30 and minus 1 upon infinite, and I know that 1 upon infinite is equals to 0. Okay, so it will simply give me minus 1 upon 30 minus 0. So the value of the focal length is minus 30 centimeter. Okay, this is what? Minus 30 centimeter. And because this focal length is in minus, so we can say that this is the focal length of a concave lens. So this lens is what? Concave lens. Okay. Now guys, your image will be formed here and you can see the image of this object here, and it can be seen by this eye. I hope guys this solution is clear to you. Now let me find out the power of this lens. Okay, because we are asked the power of this lens. So how can I do that? I know the power of the lens is 1 upon f, where f is in meter. Okay, I had explained all these things in the chapter light. Okay, so you don't need to be worried about it. So guys, what happens? I can simply put this value here. Can I put this value as it is here? No, I can't do that, because you have to keep it in your mind that this value is given in centimeter. Okay, but here the value which is to be put should be in meters. So first of all, I have to convert it in meters. So how can I convert it in meter? Simply I can multiply it by 100. So now it is converted in the meter. So what is the value of power? Let me write it here. 100 upon minus 30. 100 upon minus 30. So this 0 will be cancelled out by this 0, and the final answer is minus 10 upon 3. So this is the final answer. I hope guys this question is clear to you. So what I have done, let me again give you a quick recap. Actually, this person is having myopia. How can I find that? Because I know that the far point of in this case is not infinity, it is at 30 centimeter. So what did I do? Basically I used the lens so that the image of this object can be formed at 30 centimeter, and this image will be seen by this eye. Okay guys, so then I applied this lens formula, I calculated the focal length, and you should remember that the values to be put in this formula should be used with sign convention. It is very important. And what is the sign here? The sign should be taken negative because the both object and the image are at left side. Okay guys, then I got the focal length and I simply put this focal length in this formula. Okay, P is equals to 1 upon F after converting this focal length into the meter. Okay, then guys I got this answer. So I think these things are clear to you. Now I'm ending this lecture. Thank you so much guys, and we will meet in the later lectures. So bye bye.